Welcome, dear student of Notice to the new video on likely questions. This thing is very short, but let's continue. This is what I will use to teach. Let's look at this question, number 21. It says, the idea of planetary electron was that of what? The idea of planetary electron was that of, the answer is what? Rutherford. Niels Rutherford. Niels Rutherford. Functions. Niels Rutherford. Let me explain some things under here. The idea of planetary electron was that of what? Niels Rutherford. Rutherford is the answer. I want you to look at all these names. They are very important. In what? Discovery of atom. Discovery of atom. Discovery of what? Subatom and other things. All these names, I want you to look at it. We are Niels Bohr, Miles. We are Democritus. These two men, great men. These two great men. This was the man that first was talk about what? Atom. But he never knew the name to the word atom. That was what? 5th century before what? Christ. 5th century before what? Christ. He knew about atom, but he never what? Named atom an atom, because he didn't understand the meaning of atom. Then one of his what? Devoted disciple, Democritus, this man, now named that thing Atomos, which is what? Indivisible. Atomos, which is what? Indivisible. It was what? One of the what? Disciples of what? Niels Bohr's milestone. This man now named what his boss discovered. Atomos, which means what? Indivisible. But the man that established what? Atom scientifically. The man that established atom scientifically was what? John Dalton. John Dalton discovered what? Established what? Atoms scientifically. That is why if they ask you, father of what? Atom is what? John Dalton. He established what? Atom what? Scientifically. John Dalton established what? Atom what? Scientifically. Take note of that. This one, scientifically, he was established. This man could not establish atoms scientifically. This one could not what? Identify atoms scientifically. The first man that established atom scientifically was what? John Dalton. Take note of that. If they ask you who discovered what? Atom, the answer is what? John Dalton. Take note of that. Because he established it scientifically. Let's move. We have who we call J.J. Thomson. J.J. Thomson. Joseph John Thomson. That's the name. Joseph John Thomson. Using cathode ray experiment. Cathode ray experiment. He discovered what? Subatoms. He discovered what? Subatoms, which are what? Proton and electron. If they ask you, who discovered proton and electron? The answer is what? Joseph John Thomson, Thomson. He discovered what? Proton and what? Electron. Using what? Cathode ray experiment. What did he say? What did he say? He said these electrons are negatively charged. Negatively charged. These protons are what? Positively charged. That he now said the mistake he made. He said atom is a positively charged particle in which electrons that are negatively charged are embedded in. He said atoms are positively charged particles in which electrons which are negatively charged are embedded in. That is why he used word plum pudding experiment. Plum pudding what? Model. Plum pudding model. The name of the experiment is what? Cathode ray experiment. But plum pudding model, in which he said this is what? An atom which are positively charged. This atom is what? Positively charged. This is an atom positively charged. Then inside the atom we have electrons which are embedded, negative charge. Electrons which are embedded in what? In the positively charged what? Atom. That's what he said. Plum pudding. On the experiment or model. He said this atom is what? Positively charged. Then we have negative what? Electron which are embedded in this what? Positively charged what? Atom. Is one that discovered proton and what? Electron. Plum pudding model. Take note of that. If they ask you who discovered what? Proton and electron. The answer is what? Thomson, using cathode ray experiment. That atom is a positively charged, which is proton, which electron, which are negatively charged, are embedded in. Electron, which are negatively charged, embedded in the atom, which is what? Positively charged. Take note of that. Next one, we have Millikan. Millikan. That means Robert Andrews Millikan. Robert Andrews Millikan. Do you know what this man do? He did oil drops experiment. Oil drops experiment. Oil drop experiment. Oil drop experiment. Is there in your past question? They always ask about it. Oil drop experiment. This oil drop experiment was used to discover the charge on electron. That means it was this man discovered the charge. He discovered the charge on electron. He discovered the charge on electron. That means Robert Andrews Millikan. Oil drop experiment. He discovered the charge on electron. Let us know. The next one is Niels Rutherford. The man behind the idea of planetary of atom. Niels Rutherford. Ernest Rutherford. Using gold foil experiment. Using gold foil experiment. It's discovered the tiny what? Particles which are positively charged, and he called them what? Nucleus. Take note. If they ask you, who discovered the tiny particles which are what? Nucleus like? The answer is what? Niels Rutherford. Using what? Gold foil what? Experiment. If you want to know more about this and their calculation, there is calculation on this. join our paid class. This is where we teach you our concepts. Concept. You have to know the concept, the fact. And for you to know more, for more video, press your word, subscribe button, then share, like, and comment. Please do that. Gold foil experiment was carried out by what? Niels Rutherford to discover the tiny particles, which are called what? Nucleus. And he was the man behind the idea of what? Planetary of what? Atoms. Take note of that. Niels Rutherford. That's why the man behind the idea of what? Planetary is what? Niels Rutherford. Who first discovered the what? Tiny particles of what? Of nucleus is the same man, Niels Rutherford. We have another man called, because of time, that's why I cannot explain. Because of time, this is JAMB. We have James Chadwick. Is a great man using beryllium bombardment. He used beryllium bombardment to discover what? Neutral particles in an atom, which is known as what? Neutron. Which is known as what? Neutron. James Chadwick used what? Beryllium bombardment to discover what? A neutral particle, which is known as what? Neutron. If they ask you who discovered neutron, the answer to that question is what? James Chadwick. Discovered what? Neutron. Let's move further. Another man which we are going into is what? Niels Bohr. Niels Bohr must start with B. It must proper noun. Must start with B. Proper noun. It's a name. Proper noun. Niels Bohr. This man modified the idea of what? Planetary of what? Rutherford. If they ask you, who modified the idea of planetary of Rutherford? The answer is what? Niels Bohr. He modified the idea of planetary of what? Of atom. Niels Bohr. And this man, Niels Bohr, was the man that discovered quantum number. Which are four? We have four quantum number. He was the man that discovered quantum number. And quantum number are four. We have principal quantum number. We have azimuthal quantum number. Azimuthal quantum number is known as what? Subsidiary quantum number. It's also known as angular momentum quantum number. Azimuthal. Then we have magnetic quantum number. This one is known as subsidiary quantum number. Azimuthal is also known as subsidiary quantum number or angular momentum quantum number. We have magnetic quantum number and we have spin quantum number. Take note. Who discovered the quantum number? Niels Bohr. He also modified the idea of planetary. And the next question, what is the next question? Before we go to the next question, let me explain all this so that it will be easier for you to pick the answer. When you see any question on quantum number, you need to know. Pick your answer. Pick it. No problem. Pick it. You don't need to come on. Pick it. Just pick it. We have principal. What is principal quantum number? I'm writing principal quantum number. The symbol is N. What is principal? N. Small letter N, like this. Principal quantum number. Good. Principal quantum number. It describes the size and energy level. Write it down. It describes what? Size and what? Energy level. It describes what? Size and energy level. Oh, it describes what? Size and what? Energy level. And the symbol is what? N. When we are talking about what? Principal quantum number, we have K, N, N, N. This is the first energy level, the second energy level, the third energy level, and the fourth energy level. K, N, 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 O, P. We have it like that. But let us stop here. K, N, N, N. These are energy level. What describes the size and energy level is what? Principal. It describes the size and energy level. For you to know more about it, this, especially the JUPEP student, you have many things to know. Your A is certain for JUPEP, and for JAMB, your 90 plus is certain. It describes size and energy level. That is principal. Let's move to the next one. Azimuthal. Azimuthal, which is also known as what? Subsidiary. Subsidiary, which is also known as what? Angular momentum. It's also known as what? Angular momentum. Angular momentum. Angular momentum. Angular momentum. Angular momentum. Angular momentum. Take note, angular momentum. This one, the symbol is what? L. Small letter L. L. What is the meaning of azimuthal? Azimuthal. It describes the shape of subshell or orbital. It describes the shape of orbital or subshell. And is the one that also divides shell to subshell. It divides shell to subshell. Listen, it divides shell to what? Subshell. Shell means what? Energy level. Shell. We have shell. We have subshell. Shell, energy level. Shell means energy level. K, N, N, N. Subshell, S, P, D, F, G, H, I. This one describes the shape of this subshell, S, P, D, F. And it divides this shell to the subshell. Take note of that. It divides energy level towards sub-energy level. Shell is known as energy level. Shell, energy level. It divides the energy level to sub-energy level to subshell. Energy level is known as shell. Now divide them towards subshell or sub-energy level. SPDL. This is energy level or shell. This is subshell or sub-energy. Which one divide shell to energy level is what? Azimuthal. It describes the shape. It's also describes the shape of what? Of subshell. Let us look at those shapes. We are coming to this question. You answer the question with ease. We have S, P, D, F. These are subshell. The shape of this one is what? Spherical. Spherical in shape. And the name is what? Sharp. S is what? Subshell is what? Spherical in shape. And the name is what? Sharp. That S means sharp. The shape. This is the shape. Spherical. Name. Sharp. This one is what? Dumbbell. And the name of P is principal. The shape. This is shape. Name. Take note. Shape is spherical. Shape of this one is dumbbell. Name of this one sharp. Name of this one is principal. For this one, the shape is globular in shape. Or you can call the shape, let me write this one here, F. The shape of this one can also be called double dumbbell. dumbbell. Double dumbbell. D is what? Global in shape or double dumbbell. Global in shape, but we always put double dumbbell in most of your word question. Double dumbbell. Global or double dumbbell. The shape of F is what? Tetrahedral or complex in shape. F, let me write it. F, the shape is what? Tetrahedral or complex in shape. But the name of this one is what? Diffuse. Why the name of F is what? Fundamental. Hope you are following. I'm sorry because of we need interactive board. That's why we need your help, because we are the best in this country. We teach concept. Nobody teaches concept. We teach concept. Chemistry is very important. Chemistry makes the world. Likewise, physics. Elon Musk studied physics. That's why he could build. If you know the concept, don't just cram. Don't just look for, hey, this one said this. No, concept. We need interactive board. That's why you have to share this. We want to change educational system in this country. We want to change educational system. This country, we have brilliant students. That's why you have to subscribe, share, like, comment. And call the number for any help. We need your help also. If there's interactive board, I will be writing on the board. I'll just explain. It will make my work easier. We are the best. This is the best. Notice, is the best. Let's move further. F, the name of F is fundamental, and the shape is tetrahedral or complex. D, subshell. The name of the shape is global or double dumbbell, and the name is what? Diffuse. The name is what? Diffuse. Take note of that. What describes the shape of what? Of subshell is what? Azimuthal, subsidiary. Take note. Follow. Okay, let's move. We have magnetic. Next one, number 3. Magnetic. Quantum number. The symbol is NL. This one describes the number of orbital. And the orientation within what? Within subshell. The number of orbitals and orientation within what? Subshell. The number of orbitals and orientation within what? Subshell. The number of orbitals. That's why they tell you that S subshell has how many orbitals? 1. Take note of this. P subshell has how many orbitals? 3. 1, 2, 3. D subshell has how many orbitals? 5. 1, 2, 3, 4, 5. F subshell has how many orbitals? 7. Who described the word? Which one of them described the word? The number of orbitals. The answer is what? Magnetic. Let's go to the spin. Spin quantum number. This one describes the orientation of electron in spin or rotation in space. That's why you can see electron when filled in what? Orbital. It could be what? Clockwise or anti-clockwise. They rotate within the what? Orbital. The spin of electron within the orbital. And this one does not depend. It doesn't depend on principal. It doesn't depend on what? Azimuthal. It doesn't depend on what? On magnetic. It doesn't depend on magnetic. The symbol for this one is NS. It doesn't depend on any one of them. If they ask which of the following quantum number does not depend on what, the answer is what? Spin. It doesn't depend on anyone. It's an intrinsic property. Intrinsic property. Intrinsic. It doesn't depend. Take note of that. Then let's look at this question. Very simple. I believe that you have known this question. Which of the quantum number determine the energy sublevel? When you see sublevel, sublevel. The answer is what? Azimuthal. Don't need azimuthal. Don't get sublevel. It describes the shape of what? Subshell. It divides what? Shell into what? Sub what? Shell. It describes what? The shape of what? Subshell of orbital. Then now divide what? Shell into what? Subshell into some energy. So let's move, my people. Let's move. It's very interesting. Chemistry, very simple. And to any level, we are here with you. To any level, chemistry, we are here with you. Next one. Which of the following is not true of electrovalent bond? This is another topic. I will quickly explain this in the next 5 minutes. When we talk about bond, you have to know this. Bond. Why do elements undergo bond first? Why do elements undergo bonding? Number one, to be what? To form stable what? Octets. To form what? Stable octets. To form what? Stable what? Octets. Elements undergo bonding just to be what? Stable. They undergo bonding to be what? Stable. To form octets. To be stable. They undergo bonding to be what? Stable. But there are some elements that can undergo chemical bonding to form what? Duplets. Like hydrogen. For example, when you have hydrogen plus hydrogen to give a hydrogen molecule. This one is not stable. This one is not stable. This one is stable. This one, they are not stable. They have to come together to share electrons to form what? Hydrogen molecules. That means hydrogen gas. Hydrogen molecule. Hydrogen gas. Oxygen is not stable. They come together to share electrons to form O2. This one form what? Octets. This one form what? Duplets. Hydrogen gas form duplets. Hydrogen, oxygen molecule form what? Octet. That means the essence of what? Hydrochemical bonding is to form what? Octet or duplet, such as what? Hydrogen gas to be stable. Another one is to have low potential energy. To have low potential energy. Number two, that means chemical bonding. To have low potential energy. Oh God. This one, for better explanation, join our paid class, especially the prep student. Low potential energy. Element atoms undergo bonding to have what? Low potential energy. To form octet, hydrogen to form duplets. Let's move forward. This chemical bonding can be divided into two. Chemical bonding divided into two. We have interatomic bond. We have intermolecular bond. Interatomic bond, intermolecular bond. This is where you can see it. Interatomic bond, intermolecular bond. Under interatomic bond, we have electrovalent. Electrovalent bond. Another name for it is what? Ionic bond. We have covalent bond, which is directional bond. We have date, which is also known as coordinate. We have metallic bond, which in this one no new substance is formed. Metallic bond. In this one determines the what? The malleability, the what? The ductility of a metal, the conductivity of a metal, metallic bond. Under intermolecular bond, we have hydrogen bond, which is the strongest here. This one, hydrogen bond is the strongest among this bond. We have van der Waals bond. We have dipole. We have so many. If you want to know more, join our play class. I don't need to be giving you much here, but join our play class. Call one of the numbers on your screen. Very important. Don't forget to subscribe. Share with your friend. A place where concept is taught. Then we are going to look at them one after the other. Pick the option. Let's move. When you see electrovalent, I will quickly explain. I won't take too much time. So that electrovalent, this one, when you see metal reacting with what? Non-metal. When you see metal reacting with non-metal, the compound form will exhibit what? Electrovalent bond. For example, when you have sodium combined with chlorine gas to form sodium chloride, to form sodium what? Chloride. In this case, you have metal, sodium, non-metal, chlorine, to form sodium. This compound exhibits what? Electrovalent bond, which is also known as ionic bond. If they ask you what kind of bond occur in calcium oxide, calcium is what? Metal. Oxygen is what? Non-metal. What kind of bond? Electrovalent bond. And this compound form is known as ionic compound. Take note. Because we have types of what? Compound. We have 4 types of compound. We have ionic compound. We have molecular compound. We have what? Intermetallic compound. We have coordination compound. Complex compound. We have 4 types of compound. They will never teach you that in your school. 4 types of compound. 4. In ionic compound, what kind of bond occur in ionic compound? You can see electrovalent bond occur in ionic compound. For more video on that, for more explanation on that, join our paid class. Please join our paid class. Let's move further. Then from here, take note. When you have metal and non-metal, which form ionic bond, to determine the ionic character of an ionic bond, as metallic character increases, non-metallic character increases, ionic character also increases. If it forms ionic compound, let me say ionic compound, that means ionic character also increases. This one is metallic character. If metallic character increases, non-metallic character increases. Non-metallic character increases. That means like what? Electronegativity. Their non-metallic character increases. Then ionic character also what? Increases. Increases. Take note of that. That's why when you have aluminium chloride, sodium chloride, calcium chloride, potassium chloride. Which one of the following has the least ionic character? The answer is what? Aluminium. They have the same chlorine. But aluminum, sodium, calcium, potassium. Aluminum has the lowest what? Metallic character. Aluminum has the lowest metallic character. Sodium, potassium, calcium, they have higher metallic character than aluminum. But they have the same chlorine is the same. But this one, metallic character, is the lowest. Therefore, it has the what? Lowest ionic character. Aluminum chloride has the lowest ionic character. For more explanation, especially the level, you better join our big class. Let's move further. Or call one of those numbers on the screen. Let's move. This country will change. This country will be good. Education is backbone. And we are here to give you concept. We want to build with our students. Invent with our students. Let's move further. We have characteristics of ionic compound. Characteristics of ionic compound. Characteristics of ionic compound. Number one. Take note of this. They are soluble in polar solvent, such as water. When we get to the next question, I will explain the meaning of polar, non-polar to you. Don't worry. They are soluble in polar solvent. Electrovalent bond, all ionic bond electrovalent bond compound, ionic compound. They are soluble in what? Polar solvent. Such as that's why you see your sodium chloride, your cooking salt, table salt at home, dissolve it in water, it will dissolve. Pour it in water, it will dissolve. Soluble in polar solvent. 2. They are high melting and boiling point. High melting and boiling point. Why? Because they exhibit electrostatic force. If they ask you, what kind of force can be found in what? Electrovalent bond. It's what? Electrostatic force. Electrostatic force is found in what? Electrovalent bond. That's why they have high melting and boiling points. They can be extracted. The metals can be extracted by what? Electrolysis process. We are still coming to that. They exhibit high melting and boiling point because of what? Electrostatic force. Let's move. Number 3. They conduct current in molten and solution state. They can only conduct current in molten and solution state. Take note, they cannot conduct current in solid state. They cannot conduct current in solid state. That's why you see your sodium chloride at home in solid state, at this state, solid state, it cannot conduct current. But when it is dissolved in water, that's why they say such solution conduct current. They cannot conduct current in solid state. They can only conduct current in what? Molten or solution state. Then let us look at this question. Let's look at it. We have many explanations on this. Oh, God. Under this, we are going to explain Fassan's rule. Fassan's rule for A level, for Jupiter. Fassan's rule. We are the only one that will give you that concept. Fassan's rule. But let's look at this question because we are treating JAMB. Which of the following is not true of electrovalent bond compound? They are solid. Yes, they are solid. They do not vaporize easily. They dissolve in water. The elements forming the compound normally have what? Their valence electron in shear state. No. Electrovalent bond, let me give electrovalent bond involves transfer of electron. Electrovalent bond involves what? Transfer of electron, in which one element will lose. This one will lose electron. The non-metal will gain electron. The metal will lose electron. The non-metal will gain electron. That is, it involves transfer of electron. It doesn't involve sharing of electron. Electrovalent bond involves what? Transfer of electron, in which the metal will lose electron to be called cation. The non-metal will gain electron, it will be called what? Anion. That's why you have sodium ion and chloride ion. This one, sodium has lost electron, chlorine has what? Gained electron. That means electrovalent bond involves transfer of electron. Then, which of the following is not true of electrovalent compound? They are solid, yes. You are looking for the one that is not true. They are solid. This one is true. They are solid. They do not vaporize easily. Yes. They do not vaporize easily. Yes. Can your salt vaporize easily? No. Because they are solid. Can never be the answer. They dissolve in water. Yes. They dissolve in water. Your salt dissolve in water. Can never be the answer. The element forming the compound normally have their valence electron in shear state. No, this one is not true. This one is not true. It's not true. It's not true. The bond that involves sharing of electron is covalent bond. But electrovalent bond compound, they are solid. They do not vaporize easily. They conduct electrical current when in molten solution state. Take note. And it involves transfer of electron. But this one is not true. Let's move. Next question. Let's move to next question. And oh God. Okay. Before I move to this question, I remember something under quantum number. Take note. When you have K, N, let me just help you with this. This is shear. To know the number of electrons is what? In shear. Number of electrons in shear. We have a formula. We have subshell. To know the number of electrons in cation, okay, let me start with this one. In shell, we have 2n raised to power 2. 2n raised to power 2. This is the first shell, second shell, third shell, fourth shell. First, second, third, fourth. To know the number of electrons in K shell, K, M, N, N. That is the meaning. To know the number of electrons in what? K shell, we use the formula 2n raised to power 2. Number of electrons. To know the number of electrons in shell is there. That means 2 times for the first one. N means what? N means what? Number of shell. That means how many number of shells is 6? What number of shell? That means number of energy level. This one is the first one. N. 1 raised to power 2. That means 1 raised to power 2, 1 times 2. That means how many electrons can be found in first shell? In K shell, 2. In L shell, number of energy level or number of shell. In L shell, that means 2 times N will be what? This N will be 2 because it's the second one. 2 raised to power 2, 4 times 2. That means 8. 8 electrons here, 2 electrons here. In this one, 2 times third shell, that means N will be 3. 9 times 2, 18 electrons. This one, 2 times N will be 4 because it's the fourth shell. N will be 4 because it's the fourth shell. 4 raised to power 2, 16. 4 raised to power 2, 16. 16 times 2, 32 electrons. 32 electrons. Take note of that. Then to know the number of what? Orbital in subshell. Number, oh God. This is K shell, L shell. This is K shell, L shell, M shell, N shell. Take note. To know the number of orbital. To know the number of orbital in shell. To know the number of orbital in shell, not subshell, we use the formula n raised to power 2. To know the number of orbital in shell, we use formula n raised to power 2. This one, listen, to know the number of electron. To know the number of electron in shell is 2n raised to power 2. Number of electron in shell. Then to know the number of orbital. Please, to know the number of orbital in shell is to know the number of electron in shell is 2n raised to power 2. We shall explain. To know the number of orbital in shell, n raised to power 2. We have K shell, L shell, M shell, N shell. How many orbitals are here? This is first shell. First shell, the same way. Second shell, third shell, fourth shell. That means N will be 1. This one, how many orbitals? 1. This one, this N will be what? 2. 2 raised to power 2. How many orbitals? 4. This one, this N will be 3 raised to power. How many orbitals? 9. This one, this N will be 4 because it's the first shell. How many orbitals? 16. This is to know the number of orbital in shell. To know the number of electron in shell. Then to know, we have so many formulas. Join our big class. You can't do it. To know the number of orbital in subshell now. Number of orbitals in subshell. Not shell. Number of orbital in subshell. Number of orbital in subshell. Number of orbital. Number of orbital in subshell. That one is what? 2L plus 1. 2L plus 1. Subshell are S, P, D, F. These are subshell. Shell are K, L, N, N. These are shell. These are shell. These are subshell. To know the number of orbital in subshell, we use this formula. Take note. We write it here. We have 2L plus 1. This one is 0, 1, 2, 3. There's a reason for that. Join our big class. For this one, 0, that means 2L plus 1. L for this one, this is value of the L, 0, 1, 2, 3. L for this one is 0, that means we have 2 times 0 plus 1, which is the number of orbital here is 1. This one, 2L plus 1. L is 1, that means 2 times 1 plus 1. The number of orbital here is 3. This one, 2L plus 1, that means L is 2. That means 2 times 2 plus 1. The number of orbital is 5. This one, 2L plus 1. L is what? This value of L is 2 times 3 plus 1. The number of orbital is what? 7. That means in S of shell, number of orbital 1. That's why you have this. P of shell, the number of orbital 3. This of shell, the number of orbital 5. This one, the number of orbital 7. 1, 2, 3, 4, 5. This one is what? 7. Take note of that. But let's move further. Let's move. Very simple question. Very simple. Very simple. Let's move on. Which of the following chloride will exhibit the least ionic character? I've explained this. D. I don't need to waste much. D. Let's go to number 25. I've explained that. Number 25. We have, which of the following bond is directional? Covalent bond. Covalent bond. Covalent bond. Take note. Interatomic bond require more energy than intermolecular bond. That means interatomic bond is stronger. Atomic bond is stronger than intermolecular bond. Then among those interatomic bond, electrovalent bond is the strongest. Electrovalent bond is the strongest. Then let us look at covalent bond. Covalent bond, very covalent. Covalent involves sharing of electron. Involves what? Sharing of what? Electron. Because it involves sharing of electron, there is overlapping of orbital. There is overlapping of what? Orbital. Since there is overlapping of orbital, it is directional. It is directional. It is directional because there is overlapping of orbital. It involves what? The sharing of electron. It involves sharing of electron. Since it involves sharing of electron, there is what? Overlapping of orbital, and it is what? Directional. Both covalent bond and what? Coordinate bond, they are directional. Both what? Covalent and what? Coordinate bond are what? Directional. Take note. Because in every coordinate bond, there is covalent bond. Take note. It is direction. Involves sharing of electron, and it is what? Direction. This one, characteristics. For more explanation of this, don't let me waste our time, because this one I need to explain. When you have, for example, methane, this one is what? Non-polar. And what kind of this one? Covalent bond. When you see non-metal plus non-metal, non-metal plus non-metal, it will give you what? The compound form exhibit what? Covalent bond. For example, chlorine plus chlorine to form chlorine gas. What kind of bond? Covalent bond. Covalent bond. Hydrogen plus hydrogen to form hydrogen gas. Non-metal plus non-metal, covalent bond. Any compound that exhibit covalent bond are known as molecular compound. Molecular compound. Molecular compound exhibit what? Covalent bond. Take note. Molecular compound exhibit what? Covalent bond. When you see non-metal. Look at this. What kind of bond is found in this one? C6H12O6. What kind of bond? Covalent bond. What kind of compound? It's a molecular compound. Non-metals. It's a molecular compound. Covalent bond. When you see non-metals to form a compound, it is what? Covalent bond. That is known as a molecular compound. Take note of that. Then look at this methane, for example. I told you that we have four types of compound. We have ionic compound. We have what? Molecular compound. We have what? Intermetallic compound. We have coordinated compound. Coordinated compound. But join our pay class, you will understand better. Okay, let's move forward. I said, when you see non-metal plus non-metal, that is what? Molecular word compound. Then, when you see methane, this one is what? Non-polar. Why? Because the electronegativity difference between them is what? Less than what? 0.5. What is electronegativity of carbon? 2.5. Electronegativity of what? Hydrogen is what? 2.1. Then what is electronegativity difference? That means electronegativity difference between them. That is carbon is on 2.5 minus 2.1. The electronegativity difference is 0.4. Once electronegativity difference is less than 0.5, it is non-polar. Non-what? Polar. Non-polar. Then when you see electronegativity difference, for example, look at this. HF. Hydrogen is on 2.1. Fluorine is on 4.0. The electronegativity value of fluorine, hydrogen 2.1. Then what is electronegativity difference? 4.0 minus 2.1. The answer is from here. You have 1.9. Electronegativity difference of this one is what? 1.9. This one is what? Polar. Polar. That's why I can have this, I can have this. But when you have electronegativity difference to be greater than 1.9, that substance is what we exhibit what? Electrovalent bond. Look at this, sodium chloride. When you see sodium chloride, the electronegativity difference of sodium is 0.93. Chlorine is what? Chlorine is 3.5. Yeah, chlorine is what? 3.5 or 3.2. Okay, 3.2. What is electronegativity difference? Electronegativity difference is what? 3.2 minus 0.93. This one is more than what? 1.9. When you see electronegativity difference to be greater than 1.9, that compound will exhibit what? Electrovalent bond. Electrovalent bond. When you see electronegativity difference to be less than electronegativity difference to be less than 0.5, it is what? Non-polar, covalent. When you see electronegativity difference to be between 0.5 to 1.9, it is what? Polar. But when you see electronegativity difference to be greater than 1.9, it is what? Electrovalent. Then let's look at this. They say, which of the following bond is directional? The answer is covalent. Covalent is directional. Join our paid class for more videos. As the difference in electronegativity between bonded atoms increases, polarity also what? Increases. Take note. As the electronegativity difference increases, what happens? Look at electronegativity of this 0.4. As the electronegativity difference increases from 0.4 to 0.5, what happens? Polarity also what? Increases. The answer is increases. Take note. As electronegativity difference increases, polarity what? Increases. Then the last one, the weakest force that can, the answer to this one is what? Van der Waal is the weakest force of attraction. And this Van der Waal, take note, they will ask you, what kind of force occur in iodine crystal? The answer is what? Van der Waal. Iodine crystal is Van der Waal force. Naphthalene, Van der Waal. Nitrogen liquid. There's nitrogen liquid. Van der Waal force. Van der Waal force occur in iodine crystal, naphthalene, nitrogen liquid. It's known as what? The weakest force of attraction. Let's go to the next question. Next question, number 28. Which of the following bond does not involve the formation of new substance? That answer is metallic bond. does not involve formation of new substance. Take note. Metallic bond, let me just quickly explain bond. It does not involve the formation of what? New substance. And it occurs in an in an atom of an element. It occurs. If they ask you which of the following bond occurs in an atom of an element, is what? Metallic bond. For example, look at this sodium. This is an atom of sodium. An atom of sodium. The atomicity is 1. What kind of bond occur here? Metallic bond. Zinc, an atom, is an atom. What kind of bond? Metallic bond. It's not like this. How many atoms of oxygen do you have? 2. This one is covalent bond. This is non-metal plus non-metal to give you what? Oxygen molecule. This is what? Covalent bond. But in an atom of an element is what? Metallic bond. It does not involve the formation of a new substance. And it is responsible for what? Malleability of metals. It is responsible for conductivity of metal. It is responsible for what? For ductility of metal. That means metallic bond. And metallic bond occurs when you have metallic ion. You have a metal. The ions of the metal, which is this? Which is this? The ion of the metal. Then you have the localized electron. 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 The electrostatic force between the ion of a metal and the localized electron. The electrostatic force. The electrostatic force. Electrostatic force between the localized electron of a metal and the ion of the metal. The electrostatic force between them is known as what? Metallic bond. It is responsible for the conductivity, malleability, ductility of a metal. Take note of that. Take note of that. And it is also, look at this. Look at this. If you have sodium, magnesium, aluminum, which one of them is the heaviest? Which one of them is the heaviest? Is the hardest, right? Which one of them is the hardest? Which one of them is the hardest? The answer is what? Aluminum. Because the metallic bond of aluminum is greater than the metallic bond of magnesium, is greater than the metallic bond of sodium. Take note of that. We are coming to that when we get to what? Metals and their compound and non-metals and their compound. I will explain this better. I will give you their uses. This one is used in what? In production or in building of what? Aircraft. In building of what? Aircraft. Take note of that. Let us know. I said metallic bond. The electrostatic bond is between the ion and the what? Localized electron. The electrostatic force between the ions and the localized electron in a metal is known as what? The metallic bond. The electrostatic force between them is known as what? Metallic bond. Let us move. Okay, the next one, because of time, there's video on this. If you join our paid class, there's video on that. Let me take this clear water. Take pure water with me. Water is life. Water is what? Life. Let's go. Which of the following agents is not suitable for drying sulfide? Calcium oxide, phosphorus 5 oxides, calcium chloride, and the answer to this is what? This. The reason why this one is not suitable for drying what? H2S, because tetraoxosulfate 6 acid can react with what? H2S. Tetraoxosulfate 6 acid can dry all gases except of H2S and and what? Ammonia. Take note of that. This one, H2S, can dry all gases. H2SO4, this one, concentrated tetraisosulfate 6 acid. H2SO4, concentrated tetraisosulfate 6 acid. H2SO4 can dry all gases except what? H2S and ammonia. Why? Because it reacts with them. Take note. This topic, this question is under what? Substances which are derivative, hygroscopic, and what? Efflorescent. Hygroscopic substance and derivative substance are used as drying agent. Silica gel is the only one that can dry all gases without no exception. Silica gel can dry all gases without no exception. But this one can dry all gases with the exception. It can't dry this, it can't dry this because it reacts with them. For more explanation on this, join our paid class. Press the subscribe button, like, share. For more, because I explain substances that can be used for drying agent: calcium oxide, quicklime, calcium chloride, H2SO4, silica gel, phosphorus what? 5 oxide. Phosphorus 5 oxide. This is phosphorus 5 oxide. Phosphorus 5 oxide. This is molecular formula of phosphorus 5 oxide. The empirical formula is what? P1 P2O5. This is empirical formula. Empirical formula of phosphorus 5 oxide. This is molecular formula, empirical formula. What do they have in common? 2. Bring it out. That 2. Bring it out. P for H10, molecular formula. Bring that 2 out. You have this empirical formula. Please, if you want to know more about what hygroscopic, deliquescent, and what efflorescent, join our big class. I explain everything. This one can dry. This one can dry. The gas, this one can dry. This one is one I've explained. It can dry all gases except it cannot dry H2S and ammonia. Take note. Next question. Next question. Which of the following exists in ammonium chloride? Ammonium chloride. Ammonium chloride. Ammonium chloride. The kind of bond that occur in ammonium chloride, NH4Cl. The kind of, let us look at this. When you have NH4, Cl, minus positive, that is what? Ionic bond. First, ionic. Then in ammonium ion, because we have ammonia reacting with hydrogen ion to form ammonium ion. That means in ammonium ion, what kind of bond? Coordinate. For more of this, join our A class, coordinate. Then in ammonia itself, no metals. What kind of bond? In ammonia, what kind of bond? Covalent bond. Covalent bond. That is the answer to this. What kind of bond occur in this? Ionic coordinate, which is dative, and what? Another name for coordinate dative, covalent bond. The answer is what? We have ionic covalent dative. Take note of that. Let me quickly give you this. The shape and the bond angle of some molecules. I should have told you to join our paid class, but let me give you free. Water. Water is what? V-shape. V-shape. Or bent shape. Take note. And the bond angle of water. This is shape. The bond angle of water. Molecule. The bond shape, bond angle of water is what? 104.5 degree. Take note, 104.5 degree. We have methane, okay, is what? Tetrahedral. That's shape. The bond angle is what? 109.5 degree or 109.28 arc minutes. It's the same thing. 109 point. We have ammonia, the common one. For more explanation on this, join our work pay class. Because I taught this under what? Hybridization, how you can get the geometry, the shape, everything. Ammonia. The shape of ammonia is what? Trigonal pyramidal. Trigonal pyramidal. The bond angle is of 107 degree. Take note. We have alkene, like we have 18. The shape is of trigonal planar. The bond angle is 120 degree. We have alkyne. It's linear. The shape is 180. When you see linear shape, 180. We have oxygen gas, chlorine gas. We have fluorine gas, CO2, CO. They are also linear. Their bond angle is also what? 180 degree. Take note of that. Please, these are common. Methane, this one, we have example methane. The shape is tetrahedral, bond angle 109.5. Ammonia, trigonal pyramidal, bond angle 107. We have alkane, trigonal planar, 120 degree. Alkyne, 180. Oxygen gas, fluorine gas, hydrogen gas, linear, 180 degree. Thank you.